All right, y'all, so this is 5C. And 5C deals with statistical tables and graphs. All right, let me fix this real quick. All right, so first we'll talk about what we call data types. So this is data types. And there's two data types we'll look at. First one is qualitative data. So y'all, qualitative data consists of values that can be placed into non-numerical categories. So it consists of values that can be placed let me let one in real quick. That can be placed into non-numerical categories. So things we mean on that, some examples of non-numerical categories would be flavors of ice cream, brands of jeans, okay, so things that you cannot measure, these are just labels, colors, and things like that, okay? So next we'll look at what we call quantitative data. So your quantitative data, that will actually represent your counts or measurements. So this represents counts or measurements. All right, let me let one in real quick. So examples of quantitative data could be grades from a test, so I'm measuring your knowledge, it's a type of measurement. Heights of students, so that's another type of measurement, right? How tall are my students? So anything that you can count or measure is going to be what we call quantitative data. Also, when dealing with quantitative data categories, it is often useful to group or bin, that is called. So when I group different categories together, we're doing what we call binning. And we bin the data into categories that cover a range of possible values. So I'm going to show y'all an example in a little bit where I'm going to take a bunch of test scores and we're going to find the frequencies of them later. And I had like, I think there's going to be 20 scores. So instead of making a category for every single grade, like 70, 71, 72, 73, I binned them together in groups of 5. So I went from 70 to 75, 76 to 80, and so on. So I'm going to show you what I mean by binning when I give you that example. So here's just an example going over the qualitative and quantitative. So we want to know if these are qualitative or quantitative. So my first one, brand names of shoes in a consumer survey. So brand names of shoes in a consumer survey. All right, let me let one in here. All right, so welcome back, Valerie. All right, y'all, so is brand names of shoes, is that going to be qualitative or quantitative data, do y'all think?
Qualitative.
There you go. So I was wondering if y'all going to be shy today. So qualitative, good job. All right, because you can just label them, but you can't really measure that or count it, okay? Okay, so this one has the weights of student athletes on a team. So the weights of student athletes on a team, which y'all going with that, qualitative or quantitative? And the main thing I'm looking at on that is that things that you can measure. Because if it's things you can measure, it's definitely going to be the quantitative. All right, oh, I see a chat. Let me open up my chat box so I can see these. So chat was right. Quantitative is the right one. So I'm going to put my chat box over there where I can sort of watch it also. All righty, y'all. So let's look at frequency tables. And we'll be making frequency tables in a little bit, and you'll be able to see some of these in your homework. I believe there's like 2 or 3 frequency tables that you'll be doing in that. So frequency, to me, frequency means how many times does something happen, okay? How many A's did I have in my class? That would be the frequency of my A's and B's and C's and so forth. Now, when we do a frequency table has 2 main columns. So it's going to have 2 main columns. Now, when we do the exercises, we're going to expand that out to like 4 columns, okay? So the main columns in a frequency table, the first column is going to list all the categories of the data. So it lists all the categories of the data. So if I'm looking at grades, my categories would be A, B, C, D, and F. Okay, so that's the categories. Your second column lists the frequency of each category. So list the frequency of each category. And remember, that means which is the number of data values in that particular category. So if I was looking at test grades and I had 5 A's, 5 would be my frequency. And then I would do that for every one of my categories in my little frequency table. So we're going to expand our table to also include relative frequency, so this is going to be our first shot of doing some math in this class for a while. So relative frequency of a category is the fraction or percentage of the data values that fall in that category. So what they're talking about, if I had my 5 A's and I had 20 students in my class, then to find my relative frequency, I would take my 5 A's and divide by the 20 total students. And then I would do that for every grade and have a relative frequency for every one of my grades. So the formula for relative frequency for a category is, so y'all, here comes the first formula. Your relative frequency equals the frequency in a category divided by the total frequency. So notice this. This is the fraction. And you're always going to be dividing a smaller amount by a total amount. That means that the relative frequency, so the relative frequency for any category has to be less than or equal to 1. That's in decimal points. All right, let me let one in real quick. So if I wrote these out as decimals or fractions and added them all together, it would have to be less than or equal to 1 for each of my categories. Also, relative frequency for any category has to be less than or equal to 100%. So we'll be converting these from decimals into percents, because in the math lab, they want to know the percents as the frequencies versus the decimals. So when you add all your categories up, it's got to be 100%, which means that the relative frequency in any of your categories has to be less than that, okay? Because that 100% is the total. All right, so before we make a frequency table, we're going to also add to our table what we call the cumulative frequency. And to me, cumulative means you're sort of adding stuff together, okay? It accumulates. So the cumulative frequency of a category is the number of data values in that category and all preceding categories. So if I was doing A, B, C's and I was looking for the cumulative frequency of my C's, I would have had how many times the C's happen, how many times the B's happen, and how many times my A's happen. I would add all of them up and that would give me my cumulative frequency. All right, so I'll let y'all catch up and then we're going to make a frequency table. So if y'all ever played with frequencies, all right, y'all, so I'm going to turn my page so we can do this example. So let me see what my chat's saying. So no, so you're about to. They're not bad. All we do is a little bit of dividing and then a little bit of adding on these, okay? So y'all, let's do an example. So you want to know how to do these because you're going to do a couple of these on your homework. So this is an example. And we're going to make a frequency table. So I'm going to list out 20 scores from a 100-point exam. So we got 76, 80, 78, 76, 94, 75, 98, 77, 84, 88, 81, 72, 91, 72, 74, 86, 79, 88, 72, and 75. So let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we got our 20 scores. So let me ask y'all this. Are these scores from this test qualitative or quantitative data?
Quantitative.
There you go. Because you're counting and measuring. There you go. Good job. All righty, y'all. So our table, my first column is going to be the scores. And then we're going to find the frequency of each score. We'll do the relative frequency. And then the cumulative frequency. So now, instead of writing 20 categories for all these grades, I'm going to bend mine together. So when I bend them together, I'm going to go from 95 to 99 in that bend. Because those would be what I would consider maybe my A pluses. Then I'll bend my 90 to 94, maybe my low A's, my A minus type grades. And I'm just going to break them down all the way like that. So 85 to 89, 80 to 84, 75 to 79, and then 70 to 74. So what we'll do on the bottom will be all the totals. So I'll get my frequency and I'll find my total of that, my relative frequencies, and then my cumulative frequencies. So let me hold that paper down. They curled up because I write hard, I guess. So I need to go through my little scores and find out how many scores did I have that were between 95 and 99. So let's find them. So, oh, there's a 98. And that's it, y'all. So I had one score between 95 and 99. So now I'm going to find the scores between 90 and 94. So here's a 94. Here's a 91. And that's it. So I had two scores in that range. So you see, by bending these scores together, I got what? 1, 2, 3, 4, 6 categories versus 20 categories for all these scores. All right, y'all, let's see. 85 to 89. 85 to 89. So there's the 88, 86, and an 88. So I had 3 scores. Next is 80 to 84. So I had an 80, 84, 81. So we had 3 scores in that range. 75 to 79, 76, 78, 76, 75, 77, 79, and 75. So I did that 7 times. And then y'all 70 to 74, I had 1, 2, 3, and 4. So all these frequencies got to add up to the total number of scores that I had. So 1 and 2 is 3, plus 3 is 6, plus 3 is 9, plus 7 is 16, plus 4 is 20. So I had a total of 20 scores on that. So next, they want us to find the relative frequency. So remember, the relative frequency was the frequency of that category divided by your total frequency. So to find the first one, I would do 1 divided by 10. That gives you a decimal of 0.05. But remember, they want these written as percents in MATLAB. So you got to move them decimals right twice to turn these into percent. So if I do that, that would give me a 5%. So next I would do 2 divided by 10 because that's the frequency of that category. Oh, y'all, my bad. That's 20s on the bottom. So y'all change that to 1 divided by 20 because I had a total of 20. 1 divided by 20 gives me 0.05, which gave me 5%. The second one would be 2 divided by 20, which would be a 0.1. So remember, 0.1, you would have to add a 0 when you write that as percent to move it right twice. So that's going to give me 10%. All right, the next one we had 3. So both of these had 3 in them. So they're both going to be 3 divided by 20 for these two. So 3 divided by 20 would give you a 0.15. And 0.15 is move the decimal right twice, gives you 15%. So both of these will be 15%. All right, next I had 7 divided by 20. 7 divided by 20 is going to give you a 0.35, which turns into a 35%. All right, y'all, finally, we got 4 divided by 20. That's going to equal 0.20, or 0.2 the calculator will probably give you. So changing that to percent, we're going to add that 0 and make that a 20%. So let me show you what I was talking about. If you add all these fractions up, so remember, when you add fractions, you add the numbers on top. So 1 plus 2 is 3, plus 3 is 6, plus 3 is 9, plus 7 is 16, plus 4 is 20. So you get 20 out of 20, which is 1. So remember, the relative frequency, when you add them all together, has to equal 1. If you added all these decimals up, you'd get 1 for that. So fraction or decimal form, you're going to get 1 out of it. Also, when you add these percents, 5 plus 10 is 15, plus 15 is 30, plus 15 is 45, plus 35 is 80, and 80 plus 20 would give you 100%. So the frequencies in fraction or decimal form will give you 1. The frequencies, the relative frequencies in percent form will give you 100%. All right, y'all. So the cumulative frequency is the frequency of that data set plus all previous data sets. Well, since this was the very first data set, its cumulative frequency is 1. So the second data set, the cumulative frequency is how many times it happened, 2, plus the prior, which was 1. So your 2 plus 1 is going to give you 3. So see how it's accumulating each time? So I'll do another one and then y'all can finish me out. So this one, third data set, has a frequency of 3 plus all prior data sets would give me a 6. So y'all, who wants to give me the fourth one? So I'm looking for a chat, not seeing a chat or a voice. So y'all gonna make me do one more, then y'all are gonna do it, right?
Is it 9?
It is definitely 9 because you got 3 and then all the prior ones added up to 6. So that's definitely 9. So what I do is I take the next one and add the 9 because I know that's all the prior ones. So for the 75 to 79, we're going to get 16. So y'all finish me out. You got one more to go.
20.
20. Now check this out. This final cumulative frequency of 20 better equal your 20 that was your frequency over here. So cumulative frequency, when you're totaled up all your categories, has to equal the frequency that occurred with all the categories, okay? But this is just the way we keep track of what's happening to all the categories. So if I wanted to know, say, 85 and above, I could go over here and say, well, I had 6 scores that were at least 85 or above, okay? If I wanted to look for B's and above, then I would start at 80 to 84, and that gave me 9. So I know that 9 of my students did at least the 80. So that might be things I would use that cumulative frequency for. So y'all, I'm going to do another one so y'all can get good at these. All right, so now my chat popping up. So 20, good job. All right, y'all, so let's do another frequency table. This time I'm going to give us grades, letter grades from a class. So this is the following letter grades from a class. So I got 1, 2, 3, 5 A's. Now what's nice is this data was given to me in order. I didn't have to search through all the data to find what I needed. On the B's, we got 1, 2, 3, 4, 5, 6 B's. C's, I had 8. 8 C's, I had 4 D's, and then 1 F. So y'all, those are all the grades from this class. So we're going to create our table. This time, instead of binning them in terms of 70 to 75 type ranges I did, these I'm just going to label as grades. So I'm going to bin this one as grades. We'll find the frequency, relative frequency, now on this one, they only want me to find the relative frequency as a percent. So we're going to find these as percents. And then we'll find the cumulative frequency. So for my grades, I got 5 distinct grades showing. So I'm going to go with the A's, B's, C's, D's, and F's. Okay, down here, we're going to put our totals. Now remember, since we're doing these as a percent this time, we're doing relative frequency as a percent. Those have to add up to 100% when we're done. And then my cumulative frequency has to add to my total frequency. All right, y'all, so let's start filling it in. We said we had how many A's? I had 1, 2, 3, 4, 5 A's. B's, I had 1, 2, 3, 4, 5, 6 B's. C's, we had 1, 2, 3, 4, 5, 6, 7, 8 C's. D's, I had 4. And then 1 F. So now remember, to find those percents, I'm still going to have to do my division, and I'm going to have to turn those decimals into a percent. So for the first one, to get that relative frequency, I would do, oh, let's see, we got to add up how many we had altogether. So 5 and 6 is 11, 8 is 19, 4 is 23, plus 1, give me a total of 24. So that's what I'll be dividing each of my categories by. So the first percent, I would do 5 divided by 24. That would give you a 0.208. And I rounded that off to a 20.8%. They want me to round these to the nearest tenth, okay? So 1 decimal place. Next you would do 6 divided by 24. That would give you 0.25, and I turn that into 25%. All right, next was what? 8 divided by 24. So when I did that, I got 0.33333 forever, which I rounded that off to 33.3%. So y'all, this one had a lot of threes going on in it, okay? Anytime you do something that's a third, it's a never-ending decimal. All right, next was 4 divided by 24. That came out to around 0.1666. So I rounded that one to a 16.7%. And then finally we had what? 1 divided by 24. 1 divided by 24 gave me a 0.042. So I just rounded that to a 4.2%. All righty, so I'm going to show you. Now you won't have to put all this in here in the MATLAB. It's only going to want these percents, but this is the way I had to find them, okay? So let's see, we're going to add those together. 20.8 plus 25 plus 33.3 plus 16.7 plus the 4.2, when I hit enter, is 100%. So that sort of tells you you did good figuring out those relative frequencies. So we got 100% on that. Now they don't make you put that in there. I'm doing that so that y'all have a good way to check yourself. So now cumulative frequency. So y'all, what's the first number? So I'm looking for voice or chats.
Is it 5?
It's definitely a 5. All right, so you might as well just keep me going.
11.
11.
19. 23.
Let's see, y'all getting these participation points, right? And what was that last one?
24.
And remember, we said that the final cumulative frequency had to equal the total frequency over here. All right, so good job. Y'all are getting an idea. So now we're going to talk about different types of charts and graphs. So y'all, let me flip over so we can talk about our charts. All right, I'm trying to get my paper flat. All righty. So here we go. Bar and pie graphs. And then I'll show y'all pictures of each of these once I talk about the bar and pie graphs. So y'all probably seen them, but what does the bars and stuff actually mean on these? So a bar chart shows each category with the bar. Whose length corresponds to its frequency or relative frequency. So whose length corresponds to its frequency or relative frequency. And usually when they're doing relative frequency, they sort of like to put that in percent form, okay? So now let's look at a pie chart. So they're basically giving you the same information, except pie charts are used primarily for relative frequencies. So used primarily for relative frequencies. So they're talking about percents on those, okay? So if you see a pie chart, it's usually broken into, if I have a fourth of the pie, that would be 25% of it. If I had half of that pie, then I would have, oh, what's that, 50% of it. So they usually label what the percents of each piece is. And it's used primarily for relative frequencies because the total pie must always represent the total relative frequency of 100%. So the whole pie chart is 100%. Now, the size of each wedge is proportional to the relative frequency of that category. So the size of the wedge or piece of pie they're talking about is proportional to the relative frequency of the category it represents. So y'all, let me give y'all a second, then I'm going to pull some pictures of these two graphs first. Alrighty, so let me share my other screen and we'll look at these charts and pie charts. All right, so y'all should be seeing my PowerPoint of this. So the one on the left is definitely the bar chart. And I want y'all to notice, oh, I don't know how to do a pointer on that. Okay, never mind. I want y'all to notice on the bottom is the grades, A, B, C, D, F. That's the categories they're listing. And on the sides, on the left side, it's got it in terms of the frequency of the grade. So up here on this table 5.1, you see I had 4 A's. So if you find a column marked A, the top of its bar is as high as the 4 is on that scale. Now on the right side, they listed them as the relative frequencies as a percent. So sometimes they'll do both. Sometimes they do one or the other. Okay. Now notice we said that the pie chart mainly uses the relative frequency. So it's going to give it to you in percents. Like what percent of my class got A's? Well, that would be The 4 divided by a total of 25 would give you 16%. 7 divided by a total of 25 would give you the 28% for the B's, and so on. So remember, you're going to get a decimal and turn that decimal into a percent when you're making your pie charts. So I will say these are sort of tricky to get to the right size by hand. But if you go to something like Microsoft Excel, put in your table, it'll spit out a nice round pie chart with the pieces proportional to their amounts. And just remember, if you add all these in here together, it's going to equal 100%. So y'all's probably seen them before, but this is, now you know what's happening with those, okay? So next we're looking at histograms and line charts. So a histogram is just a bar graph for quantitative data categories. So it's a bar graph for quantitative data categories. The bars will have a natural order. And the bar widths have a specific meaning. Okay, so let me find my, well, let's talk about the line chart, and then I'll show you both of them together. And what's neat about a line chart is I always remember them because it looks like a line going through there. So the thing about a line chart is that it shows the data value for each category as a dot. And the dots are connected with lines. So the way they position these dots, so for each dot, the horizontal position so y'all, when I'm talking about horizontal position, I'm talking my left to right. Okay, so the left-right positioning of this dot is the center of the bin it represents. So if I was doing my grades from a while ago, when I was breaking my chart into 70, 75, 80, 85, 90, and so on, then my dot for each bin would be in between 80 and 85. That dot would be placed in between them in the horizontal position. Then I would have the same thing from my 85 to 90, a dot in between that, 90, 95, and so on. That's the horizontal placement of it. The vertical position is the data value for that bin. So what are they looking at? They're looking at the frequency of it. They're looking at the relative frequency of it. So I'm gonna give y'all a second to write that, and then we will look at my examples. All right, y'all, so let me share the screen with those two, and I'll sort of go through those and explain them. So I'm going to have to zip forward a little bit. And then I'll talk about that right there in a second. So on the left, you have your histogram. On the right, we have our line chart. So remember, my histogram is quantitative data. That's these scores down here. They're quantitative. They're not labeling them A, B, C, D, F. They're not labeling it as brands of shoes, brands of jeans, anything like that. They're using quantitative data scores. So they have a natural order. They're going from 70 to 100. And the bar width have meaning. So this first bar, it goes from 70 to 75. So that means that my scores in between 70 and 75, if you notice, the height of that bar equals the 4 of the frequency. So I had 4 scores between 70 and 75. Then I could do that for 75 to 80. That height equals 7. So we had 7 scores between 75 and 80, and so on. And then remember, I only had 1 score a while ago that was above 95. So that being right here between 95 and 100, its height is 1. So I had 1 there. Okay, so you look at the width of the bar is sort of like bending those scores together. Over here on my line chart, you see how this first dot is in between the 70 and 75 down here? That's what they're talking about on the horizontal placement. It's in between the 2 numbers that are detailing what that bin is. And then it's the same thing. So between 70 and 75, my dot is at the level of a 4. So that means I had 4 scores between 70 and 75. It's basically doing the same thing the bar chart done, except it's using the dots and the lines. So 75 to 80, I had 7 scores. Looks like I had 3 scores between 80 and 85. Also 3 scores between 85 and 90. So if you notice, they're similar. This one sort of goes up, and then all my scores are coming down. This one, you can tell it's going up, and then all the scores are coming down. So really, it's just whatever sort of floats your boat on which one you would use, okay? All right, y'all, so I'm going to go over one more type. So let me go back to the camera. So this one is what we call a time series graph. And guess what? It's talking about time. So that means the horizontal axis, which is like the x-axis going left to right, that axis has to represent time. So this is a graph. Well, it's a line chart or histogram in which the horizontal axis so remember, horizontal axis is going the left to right one. The horizontal axis represents time. And flows so that the time is ascending. Or descending. Now, usually time is always ascending. What they mean by ascending is it's going up in. So if I did 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. So my time is usually always going to be ascending. So right here, you're never going to really do descending time on a time graph because we want to see what's happening to it as the time goes, okay? Is it by months, hours, days? I could do by years. And I think my example is actually going to show you how it's in years. So remember, although it can be ascending or descending, I could start from the year 2020 and go backwards. It's standard common to always use the ascending order because we're used to the years adding instead of decreasing. So let me show you an example of that time series graph. So let me zoom right. So here's a time series graph. On the bottom, you'll see the years. And this one goes from, looks like 1960. Looks like it's going by, whoops, let me go back, y'all, my bad. Looks like it's going by twos all the way up to 2012. Now, on the left side, it's labeled homicides per 100,000 people. So that means 5 homicides per 100,000 people. They didn't use the whole United States and go for 330 million people. They break things down to give you better scales for these graphs, okay? So they're breaking it down per 100,000 people. So we had, looks like about 5 homicides in 1990 per 100,000 people. I'm trying to look, it looks like my highest point, the highest point was up to 10 homicides per 100,000 people. And I'm looking down and that looks like that happened around 1980. So it looks like we're doing better here in 2012. We only had back to about 5 or so per 100,000. So it's getting better, I guess. So look at things you need for these graphs. I'm going to go back and show you that slide now. So labels you want on a graph. So labels for a graph. You want a title or caption for that graph. It's got to tell me what it's about, okay? Enlist the source of the data if you can. So if you're looking at a graph that was showing who voted Republican maybe versus Democrat versus independent, you'd probably want to list the source of that data. What poll did they get that data from? Okay. You want a vertical scale and title. That's the left side going up and down. Numbers along the vertical axis should clearly indicate the scale you're using. Like that time one I just showed you said the scale was per 100,000 people, okay? So you want to definitely have a scale indicated. And the number should line up with those tick marks, okay? And then you include a label that describes the variable. Mine was talking about homicides. So mine was showing me the homicides and they scaled it per 100,000 people. And I had the scale go from, oh, what it go from 1, 2, 3, all the way up to around 10, okay? The horizontal scale going left to right on the bottom, it needs a title also. In the categories, remember, that's going to mostly show categories, the A, B, C, Ds, or was it scores from 90, 95, and so on. it should be indicated along that horizontal axis. You don't need tick marks if you're looking at categories like A, B, C, D's, and F's. Okay, they're not necessary. Now, if I was doing it where I had 70, 75, 80, when I'm bending it like that, I probably do want tick marks. So I can use the tick marks to make my bars if I needed, or have a place to place the dots for the line graphs, okay? So what's it representing? Is it time in years? Is it grades, A, B, C, D, F? Is it grades based on scores? You want to have a tidal scale for that horizontal axis. But remember, tick marks are not always necessary depending on what you're putting in there for your data. Now, a legend. Say I wanted to break scores down between boys and girls. I might have one of my lines or my bars might be blue. I might have another bar that's red. My legend would have to show me colors that were going to each of my bars. What did the red bars mean versus what does my blue bars mean, okay? I'll plot them the same way, but I'm breaking them down so that I can distinguish between the two. So, woo, y'all, that is, what was that, 5C, dealing with statistical graphs and charts, and then a little bit of frequency in there, okay? So, y'all, let me ask y'all before I let y'all go. I'm going to switch back to my pad. And we're doing qualitative or quantitative again. So this gets y'all more practice before y'all hit my homework. So flavors of an ice cream. So flavors of ice cream sold at Baskin Robbins. So I think we still got a Baskin Robbins. I'm not sure. But is that kind of data, chocolate, vanilla, strawberry, is that qualitative or quantitative? So remember, this is on y'all.
Quantitative.
Oh, what did y'all just say?
Quantitative.
I think you're saying qualitative, right? So remember, qualitative when you cannot measure it or count it. So yeah, y'all got that right on the chat. So I'm going to leave the chat open for a second. How about the annual salaries of NBA players? So annual salaries of NBA players. So I'm looking for, so that is definitely, I got it on the chat, quantitative. Good job. Also, y'all, on one of the homework problems, let me find it. You're going to make up a bar chart or you're going to choose a picture of a bar chart, and they're going to give you states and populations. When you do this, they want it in descending order. So descending order means that your bars are getting smaller from left to right. So this is descending order. Okay, so when they ask you to pick one, it's going to have you pick the populations in millions from the census data. You want the one showing your data going down in descending order. So watch those instructions sometimes, okay? Oh, let me see, y'all. I'm trying to see if there's anything else. How about this one? A movie review with a scale of 1 to 5, where 5 means excellent. This one's tricky. And y'all, this one is actually qualitative. And it's qualitative because although you see, so you got it right on there. Good job, Rachel. It's qualitative because it's an opinion. It's not something I can measure. You're just giving me your opinion on it. So it'd be like choosing a happy face on a scale of 1 to 5. A happy face was the best versus the sad face. Okay, so make sure it's something you can actually measure versus an opinion, a color, a flavor, stuff like that, okay? All right, so here's the thing on my projects. I've been getting a few projects in. So you just want to do your financing your car. You should have a car by now. You should have your loan options. So next, all you're going to do is write which loan you would pick and why would you pick that loan, okay? Now, I don't use Blackboard to submit my assignments. I've had issues with Blackboard in the past. So when you get this finished, it's in a Word document, just email that back to me, okay? Because y'all got my email address. Email it back to me, and then I print them out, and then I'm going to look at them and save them all.
Was that all stuff that you emailed to us? The
Uh,
links?
I just sent an email to y'all, and it had the file attached to it for the project.
Okay, when was that?
Oh Lord, that's been like 3 or 4 weeks.
Oh, okay. I didn't look far enough back.
Maybe search financing my car,
Okay.
and it might pull it up using them keywords because that was what my file was when I added it to it.
Thank you.
So what you do, if you cannot find that file, let me know and I will send another one. All right, y'all. So any questions from y'all? So I'll stop this recording.